name is Matthew Bevan. This is a video showing my white box testing for my NEA, which is a 3D rendering engine using ray tracing. So I'm going to start off by showing the scene that I'm using to test this white box testing. It is the same as is described in my white box testing strategy. I'm using a camera with a position and rotation of 0, 0, 0, an aspect ratio of 1 to 1, a field of view of 120, a resolution of 20, a depth of field of 1, and a blur of 0. So this is the scene I've currently got loaded. As you can see, the only camera, that's the sphere, the only camera is 0, 0, 0, 0, 0, 0, aspect ratio of 1, 1, field of view of 120, depth of field of 1, blur of 0, and resolution of 20. Additionally, the sphere is using a position of 0, 0, 8, scale of 3 to 1, a rotation of 0, 0, 0, and a radius of 2. As you can see, that's the same here, 0, 0, 8, 3, 2, 1, 0, 0, 0 for rotation, and a radius of 2. The material that the sphere is using has a color of full red, FF 0, 0, 0, 0, a roughness of approximately 0.7. The specular highlight color is FF, or full white, and the emission color is 0, 0, 0, 0, 0, 0, or full black, with an emission strength of 0.5. The expected outcome for this material would be for it to be mostly red, and in the places that are the most intensely reflective, it would be, or have the most light coming into them, it would be closer to white, and then would not be giving off any light whatsoever. So I'm going to start by running the code through the debugging mode until I come to the ray which has a direction of minus 0.29, minus 0.29, minus 0.91, which should be the first ray. So I'm going to pause the recording while I find that, and then I'll unpause it and show you that I found the correct ray. So I have just run the code until I found the ray with that same direction, minus 0.29, minus 0.29. That's getting the wrong direction currently. And then minus 0.91. So following the maths, I'm going to run the code into the collisions function method, and we should see these values line up. I won't pause and talk for all of them because many of them are very simple, such as the cam ray direction and cam ray origin are unchanged from the original ray direction and ray origin because there is no rotation in that. So I will show proof for those, but I will not show proof for the object ray origin or the adjacent or the adjustment ray rotation and such, because it's not really necessary. If the camera ray rotation is working, then so will these. So running through the program, we can see bounces equals 0, bounce limit equals 20, as it says up here. Now passing into the collisions section, these are all just instantiated at the start to make sure that it returns a value at the end, even if it doesn't collide with an object. So these are all, you can see they're getting set to values which are very obvious. So to prove that the camera rotation is being correctly accessed, I will get the values for that. Not if I keep mistyping it. There. So there's a rotation X, rotation Y, rotation Z, all 0, 0, 0. I won't be able to look at the values of the rotation matrices because they are matrices, but I will be able to look once I pass through at the ray direction, if we get there. So if I look at cam ray direction, you can see it's the same as the original direction because it shouldn't have rotated it at all, or at least very similar. There might be some change due to accuracy errors. And now if we pass one more down, we can do the same for the camera ray origin. Again, should be 0, 0, 0 as there is no rotation. So we are now going into the for loop. I've written here object equals test sphere. I just mean that it's the object that it's currently looking at is the sphere in the scene, since there is only one sphere. So looking at object.getRender, that should return true for object.getRender. If I type here again, it should there we go, object.getRender. I'll show briefly the object rotation just to prove that that is also working. Again, should be 0 because the object doesn't have a rotation. So passing through this a bit, I'll just show the object ray direction anyway, just for the sake of it. And to be clear, I'm using this getItem function because I'm using a package for the GPU, which this piece of code is currently not using, but it does also allow the use of vectors, and I can't just print out the vectors. As you can see, if I scroll over, it just gives me the object rather than returning the values. So ray direction is still the same because no rotation. Same will be for the origin. Passing through this a bit more, we reach the if statement to check that it is a sphere. So I can see here as well, object._get type should give us false, as it does. And all of these are written down here as well. So we're now up to here. The object._get type equals false. Passing down again, you can see it's tried to access the object's position. So if I just do object pos._get item 0, 0, 8, which is the sphere's position. Going down again, it's now determining the radius in every direction for the sphere. So again, if I do r.getItem, it should be 642, which I have written here. Going down again, I can see that A is 0.45. Again, it's roughly 0.45 here. It's not quite because I used an approximation of the direction, but it's roughly 0.45. You can see that B is equal to once we get past it, B is equal to minus 3.64. Again, approximation here, but roughly the same. And C should be equal to 32, which we can see in the next line here. C is equal to exactly 32. So now checking what the value of the discriminant is. The discriminant looks to be in the program roughly minus 0.6827. I have here minus 0.6849. So again, slight degree of accuracy is lost because of rounding previously, but roughly the same, which should mean that the discriminant is not greater than 0, therefore that if statement evaluates to false. Therefore, if I continue to go through this, it will move on to the next, well, it will go back to the for loop, realize there are no objects, and it will then transition out of the collisions, seeing that there are no collisions. Then it will check for did hit equals false here, and then it will move on to the next ray. So that was a test showing no collision.